lot of times that we go through life without realize that we take on energy that's not required. Just like the flame, when it's burned, it takes some energy. And but when we take on energy that's not efficient, and then showing as another yellow or red.
Yeah.
So in that sense, in life we should look at energy what is more lighter and more efficient.
Well, in terms of combustion, that yellow flame is just the result of inefficient burning and the carbon monoxide being here, and the wavelength is the yellow wavelength of light that's hitting your eye. So, and then the blue light, it's efficient burning, which without the carbon monoxide is a faster wavelength. Blue is faster, it's a more frequent vibration than yellow. So red is lower. So like the rainbow colors, the blue and the ultraviolet is highly efficient. That's why UV light can't burn your retina, and why you shouldn't stare at a UV light, because it's highly energetic photons. That's why blue light, people can't go to sleep while watching TV on their screens, because it's emitting blue light, and that's more energetic, and you have more energy, and it's hard to fall asleep. So don't look at blue light before you go to bed. But the glasses, like my glasses, have a blue blocking. They're blocking blue rays. And I had cataracts, I think, because of all the outside of the sun without wearing sunglasses. So the blue rays are hitting your retina and they cause cataracts. So that's why as you get older, it's supposed to lose some worse from all that energy messing up your lids. It's highly energetic light. That's why I'm staring at the sun. It's like there's highly energetic blue light.
So maybe
It's a higher frequency, which is good. Yeah, I love blue light, I love purples and all that, ultraviolet, but it's highly energetic. And the lower energy is red, although you can still burn. A microwave is lower than red, we can't see it. A microwave is a lower frequency, but you can still cook yourself in a microwave oven. Don't put your dog in it, because it's still the frequency, those lower waves are still vibrating those molecules, causing friction, and that'll kill you. So you don't want to, I don't stand in the microwave for my microwave, even though there's containers holding the microwaves in there. But all of it's in there.
what about like activity that excitement that people talk about?
I don't know, because light is a photon. A photon is energy. And so, photons are amazing. It's a particle.
Hey, how you doing?
Wave.
Good to see you.
Both. The wave is the frequency of the light, and then you can capture it as a particle. It depends on the detector. And then it's a particle. It acts like a particle, like an electron. So photons are like if you patch electrons together, you're emitting light. Photons are. When an electron changes from one orbital level, you have different orbital levels around the core nucleus of the neutrons. Are you familiar with that? Yeah. So electrons, when they're excited, they jump up to a higher level, and then they pop down. And when they do that, light comes off. That's how electricity works. That's Edison and Tesla and all those people.
We have the photonic technology, so there's a similar
I don't know how it's working between those two sets of Tesla coils that are going on there, but the metal in between are holding. But it's probably attracting, positive and negative attractions. And having effect on your body. Now, sometimes that can be negative if it's high energy. Like that's the problem about gamma rays from coming out of radiation, uranium. It's high. It's faster than there's blue light, ultraviolet light, X-rays, gamma rays. Gamma rays. Those are very intensely energetic frequencies, photons.
Yes.
And that can break your DNA, and when it repairs, it can make a mistake, and that's how some cancers are formed. The transcription of the DNA changes because the DNA part where the transcription factors hit it. If that was mutated accidentally during repair, then that gene may turn on constantly. And if it's a developmental gene, like when you're growing and you're making up these cells, if it's one of those genes, those cells will grow, and it's cancer. Due to high energetic waves hitting the DNA.
Could be there's some kind of traumatic experience with that circumstance happen, had the trauma, and the genetic mutation could happen, and then keep on repeating the same pattern.
The trauma is changing how your immune system is working, and your immune system actually finds these abnormal cells. It might be just one cell that has a mutation that got messed up. And that one cell, as it grows out of proportion to everything else, is taking over the whole area. And the other cells die off. So your immune system usually catches it. So we've all had cancer throughout our lives from, just sun hitting something and, just one little cell getting a mutation that caused cancer. But then your immune system is finding it and killing it. But if you're in trauma or stress or depressed, that can affect your immune system. The making of those immune cells, those little scavengers that you don't even know are working, that are grabbing it and destroying it. So your body to me is like a whole city, a country of a community of cells building you, protecting you, fighting off things. And therefore take your vitamins, eat your vegetables. Drink orange juice. Pick vitamin C. Do whatever you can to make your cells happy and let your DNA repair properly. And
So
your immune system really work strong and think positive thoughts about your immune system. You want that to be an army.
So it's kind of like that efficiency, like we're talking about the excitement. That's what our life thriving.
We're totally surrounded by all these wavelengths right now from all the lights in this room. We have neutrinos going through us right now. So far we think neutrinos are pretty cool. But so far neutrinos we think are benign. They aren't energetically messing us up as they come through us, but they're not really sure, but they're going through us right now. They're released from the sun, they're released from exploding stars out in the universe. They're one of the major particles of the universe in neutrinos. And we're capturing them down like in Antarctica.
What is neutrino?
Neutrino is like you have protons and neutrons and electrons. It's another subatomic particle. But it's smaller, so when you break, when something breaks up, those protons and neutrons, and they break apart, their building blocks start shooting out. That's including neutrinos. So our sun, you know that it's a hydrogen bomb, right? It's made of hydrogen gas. The compression due to gravity is pushing those hydrogen gas molecules together and forming helium. That's called fusion. That's a fusion bomb. That's a hydrogen bomb. That's how hydrogen bombs work. Our sun is a hydrogen bomb. It's constantly doing it. When it runs out of hydrogen, then that's when our sun dies. But it's pushing out neutrinos and other stuff from it. And all that light, photons in now, of all wavelengths. So white light is all the wavelengths. That's why we have rainbows. You shine white light through a crystal, and you can see the rainbow. It's dividing out the different wavelengths. From white light. The sun is actually sending out white light. We see this yellow because of our atmosphere. That's why we see the sky is blue. It's because the particles are spreading out, and the frequencies that we're seeing from that spreading out, the wavelengths we're seeing are blue. From when the sunlight hits the atmosphere of the Earth, that's why it looks blue.
Is that what people talk about, the blue star? Because I see that a few times.
Blue star is the energy of that star. A red star is a dying star. We have a red star. Our star is, well, it looks yellow, but it's actually white, but it's small. Right. And when it dies, we get more red. There's energy coming out from it. The bright white star is, highly energetic. Right now it's white. Oh, it's my turn.
Yes, thank you. Oh, that's beautiful. Thank you so much for sharing.
Wasn't that great?
How do you feel? Share your experience. Is it okay I record and share or no?
No.